Right, hi guys. Let's jump into the video. So at the end of class on Friday, I had you guys working through example 3, which was performing operations with complex numbers. And this very last example, I'm not sure if I got to point it out in both C and G block, but when you multiply 2 plus 3i times 2 minus 3i, these are actually called complex conjugates. And I'll define that in a second, but I want to show you what's happening. So 2 plus 3i and 2 minus 3i. What you'll notice is that the imaginary part in both of those numbers has the opposite sign, but the real part is exactly the same. And those are complex conjugates, and when you multiply them together, like I did box method here, when you actually go through the steps to simplify, that I squared is turning into -1, your middle terms that have i's in them are disappearing, and you actually end up with a solution that's a real number. So that should happen when you multiply complex conjugates together. 2 plus 3i times 2 minus 3i actually gives you a real number solution of 13. And so let's define complex conjugates more formally. So complex conjugates. Remember what the standard form of a complex number is, a plus bi. So if you're finding the complex conjugate of a plus bi, all you do is change the sign of just the imaginary part. Not the real part, that will stay the same, but the imaginary part. Therefore, the complex conjugate of a plus bi is a minus bi. And when you multiply two conjugates together, you should end up with a real number. Their product should be real. That's a formal definition of complex conjugates, and key point, when you multiply them together, you should be getting real numbers. The imaginary parts should be falling away, all right? That's your formal definition. Let's talk about dividing complex numbers now that we know what complex conjugates are. So I'm going to erase this, shift our notes, and then we'll get started with dividing complex numbers. So you've got 3 examples in this one. I'm only going to show you how to do one of them so that hopefully you guys can go through parts B and C on your own. But to divide, is this recording? Okay, it is. To divide complex numbers, like in part A. So unlike what you saw for your examples at the top of the page, adding, subtracting, and multiplying complex numbers, it's pretty much like your standard procedures for when you're working with other expressions with x. But when you're dividing complex numbers, it's different. So we actually have to use this idea of complex conjugate. So for example, dividing 4 minus 2i by -1 plus i. In order to do that division, you actually have to rationalize the denominator, and that actually requires multiplication. So what we're going to do is multiply by the complex conjugate of the denominator. Since -1 plus i is seen here, I'm going to multiply by -1 minus i, which is the conjugate of the denominator, over -1 minus i. Equivalent to 1, so I'm not changing the nature of this in any way. This is the multiplicative identity since it reduces to 1. And so if I multiply by the conjugate of the denominator here on top and bottom, when I expand, I should see that the imaginary numbers are falling away from the denominator. So to expand this out, here's what I have. In the numerator, I have to multiply 4 minus 2i times -1 minus i. And in the denominator, I have to multiply 2 complex conjugates together. And since you're multiplying 2 complex conjugates in the denominator, we know their product should be a real number. Therefore, when I do this multiplication, you shouldn't have any more i's in the bottom of this expression. If you'd like to do box method for the top piece here, that would look something like this. So 4 minus 2i and -1 minus i, multiplying the expressions at the top. So here I'm seeing 4 times -1, which is -4, -2i times -1, positive 2i. 4 times -i minus 4i, and finally -2i times -i is positive 2i squared, right? I squared, be on the lookout for that. We know it's equivalent to -1. So moving over here, I've got -4 plus 2i minus 4i plus 2i squared. And now I'm going to keep simplifying, working in the bottom, multiplying 2 complex conjugates together. We could do box method again. this time you have -1 plus I and -1 minus I. -1 times -1, positive 1, negative I times positive I, negative I. -1 times negative I, positive I, and I times negative I is negative I squared. And right here, hopefully what you see is that these two i's, negative I and positive I, will cancel each other out. So in my denominator here, I have 1 minus I plus I minus I squared. All right, so now I've done all my distribution. I've used the box method. You could use dolphin jumps if you prefer. I'm going to keep simplifying. So I'm going to combine my like terms. Anything with I will go together in the top. So 2I minus 4I. So in the numerator, I have -4. Combining like terms, -2I. And then 2 plus I squared, I know I squared is equivalent to -1, so I'm going to make that substitution. In the denominator here, I have 1. My like terms, the I terms, negative I and positive I, they cancel each other out. These are gone. So in the denominator, I have 1 minus I squared. That's 1 minus -1. So you'll notice, no more imaginary numbers in the denominator. We're rationalizing it. This is a good thing. From here, -4 minus 2, that's -6, minus 2I. Real part, imaginary part, so we're starting to see standard form. And lastly, in the bottom, 1 minus -1, that's 2. Break it apart, all right? So we want to distribute, I guess not so much distribute, but we want to break this into two different expressions. Denominator under both pieces. And you finally get -3 minus I as your final solution. So that's what you get when you divide these two complex numbers. All right, so I would recommend pausing the video at this point and take some practice with B and C. Check the answer key on Schoology. Make sure you're getting the same things I am. All right.